All right, in this section, we're going to be looking at rational functions, a new type of function. And a rational function is of the form r of x. I'll use r for rational. You can use f of x or whatever you want. R of x is equal to p of x divided by q of x, where p and q are polynomials and q is not the zero polynomial. Nobody would give it to you that way, so not super concerning, but can't divide by 0. And let's see here, for these rational functions, I'm going to write down a couple quick definition type things here. Let's say vertical asymptotes. So vertical asymptotes, this is where a simplified rational function is undefined and horizontal asymptotes, these are the end behavior of a rational function. And we'll discuss these more as we start doing examples and other things. I'm going to start, I'll keep it in this video. I'm going to start just by putting up two basic parent graphs, you could call them, our basic graphs for these rational functions. Let's start with y equals 1 over x. This is definitely one that you want to know. 1 over x, so let's see here. I'm going to give you the general shape and then I'll talk about it a little bit. So 1 over x looks something like this. And if you were to do a table of values or plug a few in, you'd kind of start seeing why it has that shape. A couple things I'll point out here. The vertical asymptote here, this is undefined at 0. You can't plug in 0 into 1 over x. So it has a vertical asymptote at 0. I'm just going to dash in a line through the y-axis. And then coincidentally here, the horizontal asymptote ends up being on the x-axis for this particular function. And again, that's the end behavior. That's what the function's doing at the two ends of the graph, at the left end and at the right end. Let's see here, we could write down, let's go ahead and write those down. So vertical asymptote was x equals 0, it was the y-axis. Horizontal asymptote was the x-axis in this case, so y equals 0. And we could, well, some things we already know. Domain, let's say. The domain here is everything except 0. And then the range, coincidentally here, ended up being the same thing, but of course on the y-axis. Including everything goes all the way up, all the way down, but there's no point at 0 either on the domain or the range here. And I'll do one more basic one like that before I start doing other examples in other videos. And we'll do one more on this introduction here. So let's say 1 over x squared is going to look similar. But x squared there, everything's going to be positive, so it will all be above the x-axis. And it happens to have the same vertical asymptote. 0 being plugged into that function would make it undefined. 0 for this horizontal asymptote as well, according to my graph. So the vertical asymptote was x equals 0. The horizontal asymptote was y equals 0. We'll see examples immediately in the next video where maybe it's not 0 for one of those, or maybe both of those. The domain here is is all real numbers except for 0. And in general, that's always going to be true. Your domain is always going to be everything other than the vertical asymptotes. And then for range here, got to be a little bit more careful with range because in this case, there's no lower portion of this graph. So this range is just 0 to infinity. So you don't want to make the exact same relationship between range and horizontal asymptotes, but domain and vertical have that relationship where anything in the domain is not a vertical asymptote. Anything that is a vertical asymptote is not in the domain.